This is a tutorial about average atomic mass. So average atomic mass is basically the way that you get the mass that you see on the periodic table. So now that we've learned about isotopes, an isotope's mass is the mass of one particular type of atom. The mass you see on the periodic table is an average of all the isotopes' masses. But it's kind of a fancy average. It's not the average you and I know. It's a little bit of a different type of average. So for example, do you remember when we talked about hydrogen and its different isotopes? There are 3 isotopes of hydrogen. And you had hydrogen 1, hydrogen 2, hydrogen 3. So one of your isotopes had a mass of 1, the other one had a mass of 2, the other one had a mass of 3. But on the periodic table, hydrogen's mass was 1.00075, something like that. How in the world did we get that mass? Why is there a decimal place in it? Well, that's what we're going to answer today, is how to get the mass that you see on the periodic table. So let's take a look at the slide. The atomic mass of an element can be calculated if you know the mass and abundance of each isotope. Abundance means how much there is of that isotope, how abundant an isotope is on the planet, meaning like how popular it is on the planet. So here's our basic equation. You take the mass of isotope A, so the first isotope, and you multiply it by its percent abundancy divided by 100. Take the mass of isotope B, it times its percent abundancy divided by 100, and you keep adding these together, and then you add the mass of isotope C times its percent abundancy divided by 100. So you might have 3 isotopes, you might have 2 isotopes, you might have 15 isotopes. If you notice, you can keep adding more of these. You can go on to isotope D and E. It just depends on your scenario. The masses, if you notice here on the bottom I've written, the unit of the masses is usually an AMU, which stands for atomic mass unit. You might also see it in grams. So let's take a look at an example. It says you have an unknown element that has 2 natural isotopes. Okay, so I'm dealing with 2 isotopes instead of 3 or 4. One isotope has a mass of 10.01 AMU. AMU stands for atomic mass unit. And its percent abundancy is 19.8%. The second isotope has a mass of 10.99 AMU. What is the percent abundance of the second isotope? What is this element's average atomic mass? And what is the element? I've got 3 questions here. So if you remember, I had 19.8% of one of the isotopes. So what's the leftover percentage for the second isotope? Well, in math, we know if you have a total, you have 100%, that's the whole part. And if I take my 1% and subtract it from 100, I get the leftover percentage. So there you go. That is the percent abundancy of the second isotope. 100 minus the first percentage gives me the remainder. I then plug it in. Remember, 10.01 was the first isotope. Its percent abundancy was 19.8. So you see that here? Don't forget, you have to take your percentage and divide it by 100 in order to get a decimal. So you might want to do that first before you plug it in. So you take 19.8 divided by 100. If the percentage confuses you, just erase it. 19.8 divided by 100, and now times that by your 10.01 AMU. And I'm going to do the same thing for the second isotope. Second isotope was 10.99 AMU. And if you remember, we just got its abundancy up here, so I plugged it in down here. Multiply it by its abundancy. Don't forget to divide the abundancy by 100 because it's a percentage and you want to turn it into a decimal. And once I do that, I get 10.8 AMU. Let's talk about sig figs. The first thing you want to do is you want to get this number. Get a big long number. Then you want to get this number. Get another big long number. And try not to chop them off. Then when you add them, you want to go to the least decimal places. If you notice, my percentage only goes to the tenths place, so my answer only goes to the tenths place. So we're trying to only do the rounding and the sig figs at the end. Now, which element is this? According to the periodic table, if I look at my elements, 10.8 matches the mass of boron. So look at the mass and see who's got a mass at 10.8. There you go.